Hello everyone. Today I have Ford Transit Connect 2006 with 1.0 non-common rail engine. So the customer complains that the car hasn't got any power, and this morning the car was brought by customer to my garage. And so let's check the car and see if the customer complaint is right. So I've connected the scanner to the car, and let's diagnose what fault code can we have. So continue. Okay. So code menu. Yeah, continue. So someone has already been here, so we have got P0000, and also we have got P0235, and the definition of the fault code is turbocharger boost sensor A circuit malfunction. So that's for the boost pressure. The code is related to the turbo boost pressure. So let's go back to the live data and see that what can we have. So back, data, ensure key is on, yes. So data may appear incorrect because some data parameters are not supported by the vehicle. Okay, continue. Okay, so we already have map sensor at inches of mercury at 1863, but I'm not sure what unit the measure is in. So here I have got the map sensor voltage. It's minus 0.030. So now the ignition is on and the engine is off. Let's start the engine and check the data if there is any change in the map sensor voltage value. So the engine is running at engine. Let's custom this one as well at engine speed as well. So I have added the engine speed as well. So as you can see, the engine is at idle and the map sensor voltage is nothing. It's minus 0.030. And now I'm going to rev the engine RPM and see if there is any changes in the map sensor value available. As you can see, the map sensor voltage value is not testing. So I'm going to add another application as well to the list, which is the engine, the vehicle speed. If yeah, I'm going to add this with that one as well. So now we have got the vehicle speed as well. Let's let's take the car to a test drive and see how the car is acting. On the instrument panel, the vehicle speed is 30 miles per hour, but on the scanner it shows only 11 miles. So I'm not sure what is the issue. Okay, now the actual speed on the dashboard on the speed meter is 35 miles per hour, but there on the scanner, as you can see, it's 11. once again I want to take the car for a test drive. I want to show you the actual speed meter which is on the vehicle dashboard, and also the data which is showing on the data screen. As you can see, the vehicle speed is that much high, and this is the scanner. And this is the vehicle actual speed. As you can see, the vehicle speed is there, and also look at the vehicle speed on the scanner, and look here. So it's huge difference. And also you saw that the map sensor voltage was not changing at all. So I'm going to do some other variant test on the vehicle. First I'm going to take the map sensor output voltage value. Then let's see what output value we will have, and then we will go for a further investigation. Another thing is that the fault code is stored in the memory in the ECM, but the engine management light is not illuminating. So another issue which we had with the car while I took the car to test drive, that on the speed meter the speed reached to 35 miles per hour, but we only had on the scanner 11 to 13 miles per hour, but that's depend on the variation of the changing the speed. So there was a huge difference between the vehicle speed meter and the data was taken by scanner. Okay, this is map sensor in the wiring diagram. So pin 1 is responsible for the 5 volt reference voltage from the ECU, and pin 2 is responsible for the signal voltage or sensor output voltage to the ECU, and pin number 3 is connected to the ground. So pin 3 is ground, pin 1 is 5 volt reference voltage supplier, and pin number 2 is the sensor output signal voltage. So we are going to first check that the reference voltage is available at sensor. Then we are going to check that whether we have a good ground. So if we connect the scanner or voltmeter to 1 and 2, if we had the reference voltage, that can prove us that we have a good ground as well. Then we are going to check the output signal, and also with the ignition on and the engine off. So we will check the value, and then we are going to put some pressure on the through the map sensor pressure receiving tube, and then we will check if the signal voltage is changing, and we will connect a separate voltmeter to this one as well, and also we will check the raising or changing this sensor value of the sensor output signal in the scanner as well. So once again, pin 1 is 5-volt reference supplier, pin 2 is signal wire, and pin 3 is the ground wire of the sensor. Okay, I have connected the scanner or the scope to the map sensor. This is the first channel lead is connected to the supply voltage of the sensor to pin 1 at the connector, and the scope black lead is connected to the battery ground. Now I'm going to turn the, as you can see, we have got 0 voltage. Now I'm going to turn the ignition on, and you watch that what value we will have on the scope screen. Yeah, as you, yeah, the probe was not properly in. Now as you can see, 4.91 volt. We have got with the ignition on, engine off, and that's the 5-volt reference voltage from the ECU to the sensor, and also that proves that we have good ground as well, because as you can see, we can read the 4.91 volt. Okay, to get a good accurate result, this time I have connected the scope negative lead to the sensor ground wire, or to the pin number 3, which is connected to the ground circuit of the sensor wire. So as you can see, we have now 4.90 volt. So again, that we have got a good ground at the sensor within the vehicle ground circuit. Okay, now I'm going to prove the sensor signal wire, so and see that what value can we have from the sensor signal wire. So this is the value that we have got right now from the sensor signal wire, and I'm going to take you to the scanner, which is connected to the DLC. Okay, as you can see, we have got here minus 0.03, so we've got nothing. So that proves that we have got problem between issue within the signal wire from the sensor to the ECU, or either that could be the ECU that's not processing the signal wire voltage through itself. So once again, we have, if you can see, it's blade that's 1.38. Okay, now I'm going to test the sensor punctuality, whether it's functioning or not. What am I going to do? What am I going to do is to put pressure, to connect pressure or direct pressure to the sensor, and then watch if the value of the signal wire is changing. And we will watch the scope, and while we directing the equals value of the manifold absolute pressure, which is created by turbo, and then see if the voltage value is changing on the signal wire. So I have disconnected the pressure tube from the manifold to the sensor, and now I have connected the tube, and the other end of the tube is connected to the let me show you. The other end of the tube is connected to the handheld vacuum and pressure pump. So I've done that. Okay, now I'm going to apply pressure to the map sensor, and you watch that if the voltage is changing. As you can see, yeah, I have applied approximately 12 psi pressure to the map sensor, as you can see here. And also, if you see that the voltage is changed from 1.38 to 3 volts now. So that proves the functionality of the map sensor, that the map sensor is properly functioning, but we have problem somewhere on the signal wire between the ECU and the sensor. So now I'm going to release the pressure back to 0. As you can see, the voltage drops back to 1.44, and as you can see now, there is no any pressure. Okay, now I'm going to go for another test, but before we do that test, now I'm going to show you the manufacturer specification for this test. The manufacturer specification is if, for example, pain point test, see if we had poor engine performance, which we have. So check the boost pressure. So using the special tool, connect the boost pressure gauge between the wastegate, control actuator, and the turbocharger. Okay, and then start and run the engine until the cooling fan has operated. So raise the engine speed to 3000 RPM and observe the reading. So as the boost pressure 0.5 bar, it means approximately 7.2, 7.3. So yes, go to future if we had the same, but already we have got a problem with the map sensor, but anyway we are going to check the boost pressure manually ourselves as well at the inlet manifold and see. So this is the specification. At 3000 rpm we should have the boost pressure 0.5 bar, but I will not be able to check at the wastegate control line, but the wastegate control pressure line and the map sensor pressure line or tube both are supplied by the inlet manifold. So we are going to check use the map sensor tube instead of the turbocharger wastegate control valve. So we are going to check the boost pressure at the map sensor tube. So they are both the same, but here the access is a bit easy to have, and then compare that pressure to the manufacturer specification, which is here. Boost pressure should be 0.5 bar. So I've started the vehicle, and now I'm going to raise the engine RPM to 3000 RPM and then see. So as you can see, the engine RPM is at 3000, and we are going to check the boost pressure with the pressure gauge. And this is the engine RPM at 3000. This is the pressure engine at idling speed. So engine at idling speed inlet manifold pressure. Once again, as the engine is idling, the map sensor data, actual data is 1.54 volts, and the inlet manifold pressure is approximately 0. And I'm going to show, I have got here 1.54 volts taking from the map sensor signal wire, and I'm going to show you once again the scanner which is connected to the DLC, and show you the map sensor signal data on the scanner screen. So this is the scanner map sensor voltage. As you can see, it's minus 0.030, and also the map inch of mercury, but I don't know actually that how do they measure this 19.5.4. Now I'm going to apply some pressure to the map sensor again and see the data here after while I have applied the pressure to the map sensor. So watch here now, we have got map sensor voltage minus 0.30, and also the map manifold absolute pressure in inch of mercury 1954.4. So pressure 0, voltage drops back to 1.49. Pressure 0, voltage drops back to 1.49. As you see here, this is the output of the sensor for the signal voltage. So that's connected to pin 34 at the ECU. So I'm going to investigate this from pin 2 at the wiring harness, pin 2, between pin 2 and 34. So if we have the signal voltage or the map sensor output voltage here, then it means that our wiring has not got any issue. So the problem is within the ECU. So if we didn't have the map sensor output signal voltage then here, then the problem is here between the within the wiring harness between the ECU and the sensor.